For decades, we've been looking at the sky asking the same question. Are we alone? And the deeper we look, the more that question refuses to go away. Because now we know, without any question, that there are billions of planets out there. Many of them are Earth-sized, many orbit stars just like our Sun. And some lie in the so-called habitable zone, that sweet spot where liquid water and possibly life could exist. We've mapped exoplanets. We've built telescopes that can peer through distant atmospheres. We even started detecting chemical fingerprints that hint towards alien biology. So with all this progress, there is something that feels odd. Why haven't we found life yet? We are closer than we've ever been. But that close feels both thrilling and frustrating. Every new discovery pushes the boundary of possibility, and yet that final confirmation that yes, life exists out there remains just out of reach. In this video, we are going to explore just how close we really are. From incredible new tools like the James Webb Space Telescope to what scientists are actually looking for when they search distant skies for life. The universe may be silent, but we are finally learning how to listen. The more we learn about the universe, the harder it is to believe we are the only ones here. Back in 1961, astronomer Frank Drake came up with a formula that tried to estimate the number of civilizations in our galaxy capable of communication. It wasn't meant to give a definitive answer, more like a way to frame the question. The Drake equation included factors like how many stars form each year, how many of those stars have planets, how many of those planets could support life, and how many might eventually develop intelligent communicating beings. At the time, we didn't know the answers to most of those variables. Today, we filled in a lot of blanks. Thanks to the missions like Kepler and TESS, we now know the planetary systems are the norm, not the exception. In fact, most stars probably have planets, and a surprising number of those planets are rocky, Earth-sized, and orbiting in the habitable zone, not too hot, not too cold. In just our galaxy alone, there could be billions of potentially habitable worlds. Billions! If life arose here on a tiny rocky planet orbiting an average star in a quiet corner of space, why wouldn't it happen elsewhere? And that's what makes this moment in science so thrilling and so frustrating. The math, the observations, the probabilities, they all point to life being everywhere. But we haven't found any. Not yet. So what's missing? Maybe we need to stop looking for Earth 2.0 and start paying closer attention to the weird, unexpected places that don't fit the rules. Because the universe isn't just full of planets, it's full of surprises. And if that blows your mind even a little, hit that like button because we are just getting started. The deeper we look, the more we find. And if you're the kind of person who loves chasing the big questions, go ahead and subscribe for more content that goes way beyond the headlines. And let me know in the comments, how many alien civilizations do you think are out there? For most of human history, we had no proof that planets even existed outside of our solar system. Today, we've confirmed over 5,000 exoplanets, and that number grows almost weekly. This discovery boom began with a spacecraft called Kepler, launched in 2009. Its mission? Stare at a single patch of sky and look for tiny, regular dips in brightness, what's known as a transit period. When a planet passes in front of its host star, it blocks a fraction of the light. That's all it takes to reveal a world light years away. Kepler didn't just detect planets, it redefined our understanding of the galaxy. It taught us that the planetary systems are incredibly common, and it showed us that small, rocky, potentially habitable planets are not rare. They are everywhere. Then came TESS, Transiting Exoplanet Survey Satellite, launched in 2018. Unlike Kepler, which studied one narrow section of the sky, TESS surveys almost the entire sky, expanding our catalogue to thousands of stars and uncovering new planetary systems in our cosmic backyard. And those aren't just gas giants or scorched wastelands. We are finding places like TRAPPIST-1, where 7 Earth-sized planets orbit a single star, 3 of them possibly in the habitable zone. Or Kepler 442b, which orbits a star similar to our Sun and could host liquid water on its surface. Or LHS 1140b, a rocky planet with a thick atmosphere that might just be perfect for life. What makes these discoveries so exciting is that they are not just dots on a map anymore. We are beginning to study them, measure their atmospheres, determine their composition, even estimate temperatures. And with the right tools, these planets become more than data points. They become candidates for life. The discovery of exoplanets was a huge leap, but now we've entered the next phase. Not just finding planets, but analyzing their atmosphere for signs of life. And this is where the James Webb Space Telescope, JWST, changes everything. Launched in late 2021, JWST is the most powerful space telescope ever built. Unlike its predecessor Hubble, which focused mostly on visible and ultraviolet light, JWST operates in the infrared spectrum. That means it can detect molecular fingerprints in the light passing through a distant planet's atmosphere. These are the clues that tell us what that atmosphere is made of. This technique is called transmission spectroscopy. When a planet passes in front of its star, some of the starlight filters through its atmosphere. JWST splits that light into its component wavelengths, like a cosmic prism, allowing scientists to identify gases like water vapor, methane, carbon dioxide, or even ozone. And why is that important? Because those molecules are biosignatures, gases that on Earth are heavily influenced by life. And JWST has already made history. It detected carbon dioxide in the atmosphere of WSP-39b, an exoplanet 700 light-years away. It's seen hazy clouds on alien worlds, mapped temperatures, and even captured the chemical makeup of hot gas giants with astonishing detail. But its biggest impact is still coming. JWST is now targeting rocky, Earth-sized exoplanets in the habitable zone, planets like TRAPPIST-1e and LHS-47b, to search for possible signs of life-friendly conditions. For the first time in history, we have the technology to look at distant worlds and ask, is something living there? And maybe even more chilling, could it know we are watching? When scientists talk about finding life, they are not expecting to see alien cities or green humanoids waving back at us. They are looking for biosignatures, indirect signs that something is alive on a distant world. So what exactly is a biosignature? It's any chemical or pattern in a planet's atmosphere, surface, or light spectrum that strongly suggests biological activity. On Earth, for example, our atmosphere is rich in oxygen, a gas that wouldn't stick around long unless something was constantly replenishing it. That something is life, mostly plants through photosynthesis. Other key biosignatures include methane, carbon dioxide, water vapor, ozone, and even nitrous oxide. But it's not about finding one of these gases in isolation, it's about finding the right combination. For instance, oxygen and methane together can signal life, because those gases destroy each other chemically. So if both are present at the same time, something must be actively producing them. But here is the catch. Abiotic processes, meaning non-biological ones, can sometimes mimic biosignatures. Volcanoes, chemical reactions, or interactions with stellar radiation can create these gases too. That's why scientists are cautious. We need not just detection, but context, understanding the planet's temperature, geology, stellar environment, and more. JWST and future missions are working towards that. And as our instruments get better, we'll be able to rule out false positives with more confidence. Because the moment we detect the right chemical fingerprint, the one that can't be explained by anything but life, that will change everything. With all planets out there, all the tools we now have, and all the signs pointing to life being likely, you have to ask, where is everybody? That's the heart of Fermi Paradox, a question first posed in the 1950s by physicist Enrico Fermi. If intelligent life is probable, and there's been plenty of time for civilizations to arise and spread across the galaxy, then why haven't we seen any signs of them? No messages, no probes, no alien megastructures lighting up the sky. Just silence. There are many possible answers, and none of them are very comfortable. One explanation is that we are just not listening properly. Maybe alien civilizations are using communication methods far beyond our current understanding. We look for radio waves and laser pulses, but what if they move to quantum entanglement, neutrino signals, or something we haven't even discovered yet? Another idea, they are staying quiet for a reason. This is the zoo hypothesis, the idea that Earth is being intentionally avoided or monitored from afar like a wildlife preserve. Civilizations might have ethical reasons not to interfere with developing species like us. Or maybe there is a darker reason. Some scientists worry that civilizations self-destruct before they ever reach the point of interstellar communication. Nuclear war, climate collapse, AI gone rogue, any number of existential threats could be common enough to wipe our intelligent life before it spreads. And then there is the chilling possibility that we are the first. It's a big galaxy, but someone has to be first, right? Either way, the Fermi Paradox isn't just a puzzle. It's a mirror forcing us to ask what kind of species we are, and what kind we want to become if we're truly alone, or if someone's out there watching us. So how close are we to discovering alien life? The answer might be closer than we've ever been, but not just quite there yet. We moved from simply wondering if planets exist to confirming thousands of them. We've gone from scanning static to analyzing the chemical makeup of alien atmospheres. We are no longer guessing, we are measuring. And that's a monumental leap forward. With the James Webb Space Telescope, we now have the ability to peer into the atmospheres of rocky, Earth-sized planets orbiting stars just a few dozen light years away. We are detecting things like carbon dioxide, water vapor, and temperature profiles with a level of precision we only dreamt of a decade ago. Add to that the upcoming missions like ESA's Ariel, NASA's LUVOIR, and the next-gen extremely large telescopes here on Earth. And the search is about to explode with new data. But finding life, real life, will take more than just a strong detection. It will require multiple biosignatures, cross-confirmed by different instruments studied over time. And that's what makes this moment so exciting. We are not waiting for sci-fi contact scenarios or blinking lights in the sky. We are following a trail of evidence that's getting clearer step by step. If life is out there, we are finally equipped to find it. And if we don't, that might be the most profound answer of all. Because either we are about to make the biggest discovery in human history, or we are the first spark of awareness in very quiet cosmos. Right now, the universe is silent. But maybe it's not because no one's out there. Maybe it's just because we are finally learning how to listen. For the first time in history, we have the tools, the data, and the vision to search for life beyond Earth in a meaningful way. Not through science fiction, not through wishful thinking, but through real observation, real measurement, and real science. And while we haven't found life yet, the progress we've made in just last few years is astonishing. We confirmed Earth-sized planets in habitable zones, we've identified atmospheric molecules that might signal biological activity, and we are building telescopes that will see further and clearer than anything we've ever launched. The silence might feel discouraging. But remember, we are still at the very beginning. The universe is enormous. It's billions of years old, and we've only just begun to explore a fraction of it. If life is rare, then our discovery will be priceless. And if life is common, then the silence may be temporary. Either way, the search changes us. It forces us to look outward, ask bigger questions, and understand our place in the cosmos. Because whether we are alone or not, the journey to find out is just as powerful as the answer. Thank you for watching. Keep looking up.